All right, thanks everyone for joining in the StepWin webinar. Yeah, we have still people coming in, but I think it's time to start. Okay, a few housekeeping items first. If you have any issues with the sound, you cannot hear me or also if you're joining by the live stream and you want to ask questions, you can feel free to join via phone. If you have any issues inside Google Meet, you can also try live.lambda.science. That will take you right to our live stream. We have a few people joining through that, and that's kind of our backup plan for today. Other than that, if you have any questions, please feel free to unmute yourself and ask the question. We also have the chat, so we are also going to be monitoring the chat and answer any questions you may have. Now, about the StepWin, I think most of you hopefully know the story that we started it back in 2017 when we saw how quickly it can become very complicated and costly for builders to meet the step code. We were seeing situations like where the expenditure and the performance of the building were not aligning really well. This is one example of that. You have over expenditure on different assemblies in the building, and then some of the building is not performing as well as it should. Given that the costs are lower, the material is also lower performing. Now, when you give this to the energy modeling software, it's not going to give you really good results. And the reason is that all of the heat it tends to be escaping, for example, in this case, from the window. However, if you give this to a StepWin, what it does is that it will give you a more harmonized design. It will find sort of the in simple terms the best bang for the buck, as what materials or assemblies are going to perform okay at a very good pricing point, and then overall your costing and performance are going to be much more aligned. You may have heard it from us before that if you go skiing in shorts, you will be uncomfortable no matter how many jackets you put on. And this is the exact example of not putting the right insulations in the right places. Is that if somebody goes skiing in shorts and when they feel uncomfortable, they add on more jackets, they are not addressing where the heat is escaping from. So in this example of this home, you have all of the insulations going inside the walls and roofs. But when it comes to, for example, windows, which are a very significant part of heat loss, they are not performing as well as they should. So today what we are going to do is that we are going to go ahead and design a home with a StepWin. The goal for today is to pick up a design and go over different aspects of it and also fill a StepWin in as we go forward, see the result and see how it can help significantly speed up and simplify a step code compliant home. Now, if you want to do this process on your own, the BC Step Code Metrics study showed that there are 54 million possible assembly combinations that are available to a builder to build a home in one particular design. And very quickly, we realized that with today's tooling and systems, we are not really able to go over all of these and make a meaningful and thorough assessment of what is out there. So what StepWin comes into view is at the very earliest stage of the design, where the builder is just preparing to create a very preliminary design, or the decision maker. It could be the architect, it could be even the energy advisors themselves, the person who is in charge of energy efficiency, and also the budget considerations of that inside their project. So that's where we come in a very early stage of the design. We help you come up with your one out of that whole 54 million. And then when you are quite prepared to narrow down on that design and continue on with it, you can take it to your energy advisor. This is one of the real examples. This is a very simple laneway house we had. This is the level of detail essentially that you need to get us started with the StepWin. We really made sure that we are trying to be available at a very early stage of the design, so we don't ask too many difficult questions. We just try to be as simple as we can. So in this case, they had a simple laneway house. Because of the slope of the ground, they wanted to do half of it basement, half of it crawl space. They had a somewhat of a deck, and then the red thing you see here is the entrance door. All of those green ones are the windows. And they were also not sure if they want to do a window along the south because of some privacy concerns. And they want to know if that is going to be good for the step code or bad for the step code, and make their decisions based on that. So from the get-go, you see the design is not really, we are not asking really for all that much, just the rough dimensions of these, what sort of facing and what sort of windows you're going to have, what sort of foundation you want to have, and what sort of roof you have. Now, what we will do today is to work on a design that was inspired by a City of Kelowna design. We are going to go around it and see what sort of inputs are needed to make a StepWin work and assess this design. Before I get this started, I just want to see if there are any questions. So you can use the chat. You can use, if you're on the live stream, feel free to use the chat there. Okay, no one there. All right, assuming there are no questions. Yes, okay, so we're gonna work on a design. So let's say this is just the very first thing is the architect or the builder or anyone basically is looking at that lot. They close their eyes, they kind of visualize what they want to have built in there. So this is like the shape of the first floor. They're going to have a parking near the corner. Now this first floor is going to have all of those walls, and the rooms are going to be separated and whatnot, but those are not important for us. They will also say that they're going to put a second floor that's somewhat smaller on top of it. So that's the stage they can get started with the StepWin. Okay, so now to get started, what they need to do is to go to web.stepwin.ca. That's our website. As soon as you go in, there is a welcome screen. It's asking you to put in your work email and password. Thinking that you don't have an email or password, you can click on sign up. Now, one thing that we have to highlight, as you saw in the welcome screen in the live stream, if welcome screen, we are right now providing services in the City of Kelowna, City of Penticton, City of Port Moody, and City of New Westminster. This is open for all of the builders to create an account, but when you reach the stage that you are going to put the location of the house, we are expecting it to be in one of those four regions. Other than that, everyone is able to create an account, and gradually we are going to try to expand these regions and hopefully provide the service available everywhere. Okay, so the first thing I need to do is to add in my work email. So we can say demo webinar. This is one of the emails we have at stepwin.ca. Let me, sorry, demo webinar, stepwin.ca. That should be good. Then I will put the password. I will put in my own name, company. So here you put in your company and a phone number. So one thing I want to highlight is that please make sure you put the full phone number with +1, and also don't put in any spaces. We are not, right now we just say something is wrong, but it's probably because of the phone number. So just like every person can have one email, we are expecting that also one phone number for every account. So two accounts cannot have the same phone number. The phone number we are collecting is because if you are having a ticket with us for some sort of a question or issue, it might be faster that we connect with you through that. Also, in the future we may use it for two-factor authentication, that we will send you a text with a code, but that's not the case, at least for now. Okay, so I'm gonna put in my phone number, and this is my actual phone number. You can reach me with this, and if you want to join our newsletter, you can do that as well. I'm not going to do that because I'm the one making the newsletter. So click on sign up. It will take a few. Oh, okay. So I have an issue here. Let me just change this. Oh yeah, there you go. Let's see, March. Probably a wrong email. Okay, password, company. Yeah, that should be fine. Okay, 6. Oh, sorry. There you go. Sign up. So okay, so it was successful. So I created my account now. All I need to do is to press enter here. So now I log in into my own account. Then the first thing I'll see on the screen is instructions of how to use StepWin. So we have a ribbon on the left that is here. So as you hover over it, you see different options showing up. So starting from the top to bottom, we will navigate through this. This screen also tells you what you will need to get started, and that's basically what I went over. So I'm going to click on climate. Here we ask for that job address. As I was mentioning, we expect this to be in one of the 4 city regions. I will just put in our address in our downtown office here. So in downtown Vancouver. So as soon as I put in this address, it will go and try to fetch information for it. So right now it's just connected to Vancouver Constellation successfully. Now the reason I'm really putting emphasis on the address is that a constellation for us is the costing data, the climate data, the energy efficiency, regional government energy efficiency laws. So once you, for example, put in an address in the city of Kelowna, we are going to take that information from our database from the city of Kelowna. So then you will actually build to a correct climate file. But if you don't do this correctly, then the climate files or the costing data may be inaccurate, and you definitely don't want that. Okay, so going back to the design we have, as we move to the general page, we will see very simple introduction of different building features. As we mentioned, this is a 2-story building, so keep in mind this is above grade floors. So 2 stories above grade. Then we want to talk about our roof. So assuming that you will have a cathedral roof on the second floor, and then there is a difference. Like there is also the first floor needs to be covered, and let's imagine that the builder is going to talk about the team comes up with an attic for that first floor difference. So you will have a attic roof for the first floor and a cathedral roof for the second floor, or a mixture of the two throughout the house. So I'm going to go on the roofs. I'm going to click on hip attic. Assuming that it's going to be hip, and also the cathedral roof. And if you're unsure about the difference, in the cathedral roof, the insulation is along the sloped roof line, but in the attic, you have a continuous line of insulation along the bottom, and then the attic space is basically empty. The insulation is not along the sloped roof. Also, let's say that the builder is going to use a basement for this. So I'll click on the basement, and when I click on this, you will see a few extra options are showing up at the bottom, and these are the kind of the additional questions we are asking about the shape of the house before proceeding any further. The first thing we are asking here is the house heated space. This house heated space is because you have a cathedral roof. For most of the other options, we can calculate this. This heated space, imagine the amount of air that is in the home encapsulates in every floor. Whenever you see these icons, if you hover over them, it will tell you what we are looking for in particular. So I am going to go ahead and put in the number we already had hold on just 1 second. Yeah, so this is a square meter. This is cubic meter. If you are unfamiliar or unwilling to put in the cubic meter, you can just simply click on it. Now it will become the imperial system. So 35,000 is a number that it had come we had come up with in terms of the volume of the house we are going to encapsulate, and this is just simply the area of every floor times the height of that floor. The second item here is exposed floor. So as you're seeing here, so the exposed floor is the extension of the house outside of outside of the envelope. We also are asking for adjacent unheated spaces. Now think about the storage spaces and garages and how they interface with the rest of the building. So to figure all of these things out, let's think about the house as in terms of how it interfaces with the environment. This is our first floor. We have the parking. So just think about the exterior wall. And this is kind of the way I always approach every design. So think about the exterior wall in this first floor. We have the parking here. Now, if the parking is unheated, I mean, at least it's not as heated as the rest of the house. It just has its separate heater. The interface of the living space you have in the first floor is going to be also with the parking as well. I mean, you have to put the insulation between the first floor and the parking. So at this stage, we start to think about our envelope line and how it's passing through different assemblies. When we have the parking being unheated, we pass the insulation line from between the parking and the first floor. So keep that in mind. Now we say, okay, this is our first floor. This is our envelope line that goes all around the first floor. Then when we put the second floor on top of it, now we see the differences between them. We have we have the second floor only covering a part of the first floor, so the rest of it becomes the roof. Now, if you had the second floor somewhat extending from um, outside of the boundaries of the first floor. For example, it was extending from the exterior in the upper circle. Then you would have you would fill the exposed floor section, which is you would put the sum of the areas of all of the exposed floors, and you would add it here. If you had an exposed floor that was going on top of, for example, this garage, now thinking about the adjacent unheated spaces, that's also where we put in the information about that. In this example, we don't have any of those. Second floor is sitting right on top of the first floor. The parking space that is interfacing with the first floor, we only have a wall between the first floor and that parking area. So that's still an unheated space. So whatever unheated space you have, think about the wall areas, how they are interfacing with the rest of the building. You can just put the total wall area of those unheated spaces. It could be a garage, it could be a storage space, whatever that is not being as heated as the rest of the home in here. So we had 418. Now this floor option does not apply here because we don't have this garage does not have any heated floors on top of it. That's just on its own. It's sitting and there is gonna be a roof on top of it. But in the case that we had like the second floor coming on top of it, this area that was from the second floor also would have been you would put the area in there. Okay, so now that we figured out the adjacent unheated spaces, we are going to exclude the parking from the rest of the work. So the parking does not apply anymore. It was an unheated space adjacent to our primary building, and we're just going to exclude that from everything else. Okay, so moving on to the roof, as we have to the roof page, as we have put in the cathedral roof and attic roof, is going to ask us further information about those two. Here I have the slope of the roof. So if you hover over this slope, as it also has one of those kind of eye thingies, small icons, as you hover over it, it gives you a handy chart that what sort of number in terms of a slope you are looking for. If you say that, for example, your pitch here was 6 by 12, that translates to 0.5 in our software. So I would put in 0.5, sorry. And then I will put the sloped area. So for us, the cathedral roof, the area was 270 square feet. Okay, now you also can put skylights inside the cathedral roof. Here we had a northwest skylight, width of 6, height of 6. It's a picture. Typically, skylights are picture because nobody goes up there to open them. Southwest facing, 4 and 3, and also this one is a picture. And if you want to add more, you can simply click on Add New. If you want to remove any of them, you can simply click on Remove. Moving on, if I want to go to the next page, it's going to tell me that, hey, you haven't really done your ceiling area. So here I can click on the ceiling area. 1768 was the number we had after calculating these, basically. Now, we are going to also talk about the assemblies here. Here we have two options for the exterior insulated and also interior insulated cathedral roof. Also for the attic, we can blow in 12 inches or we can blow in 18 inches. If it doesn't really make a big difference for you cost-wise, you don't really mind putting in, for example, 18-inch here, you can easily remove one of the choices and only have one of them. If you are considering another assembly that you want to add, another R value, you can also go ahead and do that. If you hover over these options, we will give you a particular R value and what sort of components we have considered in this assembly. So this is 37.9 and 26.8. Let's say you have another assembly that's kind of between these two, but you still want to assess it, and the R value of that is 32. So when I click on add new, I can have a R value of 32. Let's say my Cathedral Roof. I'm just going to give it a name. Make sure you give it a name. Okay, and now we come down to costing. So we are asking you what sort of material cost and what labor cost per square foot you will be looking at. If you're not sure what to put in here, this eye icon in the corner is going to tell you what numbers we are looking for. Also, make sure that the R value is the effective R value, not the R value of your insulation. Now, if your assumptions for the costing is different than what we have inside our software, the stuff that we are asking you, make sure that you remove all of our default options and go on, make all of your assemblies on your own manually, and put in your own costing data. So I'm just gonna add these two here. I'm not gonna put any sort of custom assemblies, but you're more than welcome to go ahead and do that. Moving on to the main floor, I have 4 options that we have put in for our wall. It's double stud wall, split insulated, and whatnot. If you hover over them, we tell you the assumptions we have for these. For you folks in the Okanagan region, people who are joining from there, I know that drain screen might not be something you're using for your project. It might make a small difference, but if you think the difference is going to be significant enough, please feel free to go ahead and add new. We typically don't consider a significant role for the rain screen inside our R value calculations, and inside the costing, all of the cladding assemblies are the same. So the relative difference you're going to get in terms of costing is not going to be impacted by these. But let's move on. Think about that you don't want to do the double stud wall, so you're going to remove that, but you would like to consider all of the options, all of the other options. So you want to see how would a split insulated wall do, how would the exterior insulated wall do, and a deep stud wall. And if there is anything else you want to test, you can add it again. Again, R value, material, and labor cost, and a name is all we are asking for here. And when we do that, then we are going to move on and move towards our floor dimensions. So as you see, we are asking for very basic things here. We are asking for area and perimeter. Here, it's really easy for you to just go around this line, find the exterior perimeter of the house. Keep in mind that you have already considered the parking part as well, so you exclude that parking piece from the rest of your assemblies. So you go around and get the perimeter of all around the first floor except for the parking, and you put the number here. So the number for our perimeter is 173. Just the same way, I'm gonna go and find the area of my first floor. So the area is gonna be 1680. And then the wall height, we have set 9 feet. Again, if you are more familiar with the metric system or want to use that, simply click on this. It's going to give you all sorts of units. So a few times I click it, I'm going to reach metric. But, imperial system is, I guess, the common practice. Okay, second floor, we have a similar situation. 1051, perimeter 160, and a wall height of 8. So again, like I go to my second floor, put in the information about it. Now I come to my windows and doors. So I put in all of the windows I have, all of the patio doors and everything like that. So starting with the one northeast facing 14 by 7 patio door, and then I can just click on add new and start like adding more. I am going to leave this for the sake of just not taking too much time, but that's how essentially you start filling up. So this is an entrance door. You can just put in an entrance door, garage door, patio door, or if you have a picture window which is unoperable, you use picture. If you have a hinged window, which is also called casement, you can use that, and the sliders are basically, yeah, the slider window. So this one is an entrance door. I'm going to just skip to the next one. Okay, so now let's look at basement. So here we are asking you to think about the basement walls, exposed areas, and in-soil area. To clarify what I'm looking at, we have created a very rough generic model of this house. Think about it, think about this house looking this way. So we had the first floor, which we just worked on, sitting kind of on a slope. So you have the entrances going in from the top. Then you have the second floor sitting right on top of it. And then as the ground kind of slopes down, you have more of the basement being exposed. So you have some windows that's sticking out from there, and you have like more, some of the wall of the basement is gonna be also exposed. So think about it that way. Now, so moving on to like the basement itself. I had the parking area, and the parking area is a slab on grade. It's gonna be, the soil is gonna be filled like underneath it. So my basement wall is gonna be facing soil in that region. The rest of the basement, the soil, like part of it is gonna face the soil, part of it is gonna face the elements. So I calculate the total area of my basement wall, that is the other side of it is basically soil. Also the total area of the basement wall that is facing the air. So in this case it's gonna be the brown part versus the white part. One thing to note, if you have a window well, make sure that you also consider that part as exposed, because it's not touching soil. So imagine like you are walking around from inside the basement, whatever area that is touching the soil is gonna go into the StepWin's in-soil area, and whatever that's not touching the soil is gonna be in the exposed area. So doing that, our area was 338, inside area was 822. We also have an option for the pony wall. So sometimes people are not extending the slab concrete all the way to the first floor or whatever floor joist is up there. They put a pony wall between that. So if you have a pony wall, make sure that you are not putting it inside the exposed area. You are separately putting it inside the pony wall area. We didn't have any here. All right, now moving on to the slabs. Here, as you see, we have different configurations for the slab, how the insulation is going to be put in. If for whatever reason you cannot do a continuous installation, we have an option for that too. Now these installations are kind of the bases. If you want to do something else, again, feel free to click on add new. You will have an option to add your own R value. If you are unsure that your costing is going to be compatible with our default, make sure you turn off all of our options and put in all of yours, or just do a mixture of the two. So right now we are looking at putting the slab, putting the insulation only in the bottom, and putting the insulation only at the top. The frost line is gonna make a difference here, so I'm not gonna alter these scenarios. Moving on to the next page. In the next page, we are going to ask you for the basement wall. So the way this interface is working, and I think this is important to note. The combinations of the interior and the exterior is whatever we are going to choose. So when you have two choices here and two choices here, we will have a total of 4 choices. We will get one time no exterior insulation and also fully insulated below grade exterior insulation. One time we get no insulation exterior, no insulation interior, fully insulated exterior. One time we get like the fully insulated interior with this and this, so you have some sort of an ICF. If you only want to do an ICF, you can just go ahead and erase everything else. So you will have fully insulated interior wall and you have fully insulated exterior wall. That's going to be an ICF option. If you want to add anything new, you can just click on that as well, and add insulation for the inside or outside, depending on what you want. We also have, as you saw in the 3D model, we have also a few windows sticking out. So this is where we can add those windows as well. So let's say 4x7, southeast facing, and the type is a slider. Okay, I'm gonna take a pause. Any questions so far? Please feel free to unmute yourself, or just send it in chat. Okay, so either I'm doing a perfect job of explaining everything, or I'm doing a terrible job. One of these two. Okay, so moving on to the window part. Looking at the window options, this is more about aesthetics, as well as the amount of coating you want to have on your windows. So the first thing, the top part is the window frame, double glaze, triple glaze, and also the sort of framing you want to have for it. Here we have PVC and wood options by default. Let's say you're not considering any of the double glaze, so you can turn them off if you want, and again you can add the ones you want. The second part is also extremely important. This comes down to the solar heat gain coefficient. So your window manufacturer will have a few words on this. We have different levels of solar heat gain coefficient put in here. So for example, here we have a tinted glass because the solar heat gain coefficient is just like really low. But it really depends on what your window manufacturer is telling you about the numbers they can provide. So feel free to put in to enable whatever number that they have, whatever number of window solar heat gain coefficient they may have. And finally, we move on to the mechanical page. So you have a primary mechanical system. This could be a combo system, baseboard, boiler, or furnace. These are the typical choices. For the auxiliary or heat pump, air conditioning, air source heat pump. Also domestic hot water, we have just the common choices, and the ventilation heat recovery. Now, I already have a pre-filled version of this filled in here. So we have gone ahead and put all of the information about all of the walls and windows and all of that in there. But that's also what you can do. It doesn't take a long time for putting all of these information in. And once you are really comfortable with everything from climate through mechanical page, you can click on the run screen. And when you click on the run screen, it's going to give you a refresh button here. When you click on that refresh button, it's going to start the simulations. This will take a few minutes until we kind of start communicating with the server and send out all of your options to the server, and then have the server start doing the simulations. Now, what we are doing right now is that we are taking in all of the combinations that you had, all of the options that you put in. For example, we had 3 walls and we had like 2 windows and 2 window solar heat gain coefficients. We are mixing and matching every single one of those, and we are doing a simulation of that. We are also costing all of them out. So when we see an option that is doing cheaply for one of the steps, we are cherry picking that option and we are showing it to you here. Now here, this is the last stage of our simulation. I think the last number I saw, I think it did about like 8,000 design combinations to it has cherry picked only a few of them that have performed really well. What it is doing right now is it's performing just the final stage, and it's complete. So as you click on one of these designs, what it will pull up for you is the strategy that and made this design good, made this design perform well. It's going to give you some numbers about why it is performing really well. It's also going to give you the total energy related cost. This is not your finishings, this is not your interior walls or whatever. This is only the stuff that have to do with energy, and essentially the numbers we put in the previous sections. It's going to meet the step 4. We have a few step code metrics here as well. Now we have a brand new feature. We are just showing this. You're the first people who are seeing this, and this is the loads. So we are showing also some of the loads. Oh, impressive solar heat gain from this design. We have the envelope heat loss. We have the usable internal gains. This is from occupancy, appliances, whatever, and usable solar gain. So you see how the house is kind of like offsetting some of that envelope heat loss with the help of some of those internal gains. But in the meantime, you also can get a feel of how much sun each different design is bringing in and how much envelope heat loss they are experiencing. And as you see, in January, we have quite significant envelope heat loss, of course, because the outside is very cold. When we go to summer, it's much less. Maybe it's on a cold summer night, and then we go back towards the end of the year, and we still like get a lot of that again. You can filter out whichever you don't want to see. Maybe you want to see how much solar heat gain your home is getting, and this is only usable portion of it. But this design is doing pretty well because it's inviting in a lot of sun, especially in the colder months, as you are seeing, and that's going to do very well with offsetting all of your unwanted kind of heat loss that you're getting out of it. The other things we are showing in this reporter screen is a clamshell graph showing you how much each of your designs are each of the parts of the building are going to cost you. Typically the ones that are larger and there is more insulation in them, they are going to do that. Then we are going to talk about which of the walls was chosen for this design. So we picked up, for example, the first one that met step 4. This one is a split insulated wall. Now, knowing that not everybody is familiar with all of the assemblies that are going into a StepWin, we have also secured copywriting from BC Housing. And with that, we have been able to incorporate their illustrated guide inside our software. If I click, for example, on our 22 plus guide here, it will take me to that guide and also the particular page this design has been featured on. So you have a very handy quick summary of how this wall is performing in different aspects of it, the constructability, considerations of that. You also have a very handy sheet for adjusting the R value of it based on if you are making any modifications. We have many more resources all throughout the reporting screen, such as let's say the Canadian Wood Council, the most similar choice that is there. They are also having quite handy sheets there about which climates they are gonna like. This is gonna work well with the drawing potentials and costing considerations and all of it. Moving on, we have also these informations for the roofs, attics, whatever you have in your house. We give you very detailed information about what sort of window we have. We think this design is doing well with. So you can just pass this to your window manufacturer and ask them what they have along these lines. You have the mechanical systems, the assumptions and all of that. And also you have the cost breakdown. The cost breakdown is also gonna tell you what are our assumptions in terms of costing, and if something is not quite making sense, you can adjust it in the previous pages. Now, in these arc of getting the design, I still have a lot of things to say, but if you have any issues, you can easily click on this chat function in the corner, and you can send any question you have our way, and we will be there to help you navigate through the software. Now, let's say I'm not looking for a step 4 in particular, I'm looking for a step 3. What I can click on filter by step. I can pick up a step 3. This is going to cost me less, showing with $1 sign. So I will click in this one. So the strategy for this case was using passive heat gain. So this one is actually inviting even more sun inside to offset those envelope heat losses when the weather is cold. So it's performing really well. Then we have the step code metrics, which is TEDI, MUI. These are the stuff that the energy advisor is going to use. Okay, so let's say you like this design, you want to have it somewhere safe. So what you can do is to click on this star icon. What this star icon does is that it puts this design into your compare sheet. And when I click on the compare sheet, we previously had a few of the designs starting here. This compare sheet is gonna help me kind of keep track of whatever I'm doing inside StepWin. Let's say I want to make sure that my design is performing. This design, for example, has the windows that I was considering whether I want to put them in or not. So I can say, windows along the south. And if I want to like test something else, if I want to like remove those windows, see how they are performing, I can go back into my main section, adjust the windows however I want, go back to the run, get my run, start the design that I want, and once I have start my design, I can also go into the compare sheet and make a make my comparisons there. Now, let's say you found the design that you really wanted. This is the perfect design. Couldn't get any better than that. You can share this with your energy advisor or whoever that is going to have another say in the design. The other handy options we are giving you is to get a printout of this design or save it as PDF if you want. So this is generating that. We give all of the information you have put in plus the result of this design into a very handy sheet for you, so that you can show it to other people or just keep it somewhere that you can refer to later. The other feature that is going to hopefully be tremendously helpful is our Hot 2000 exporting option. So when you came up with one design, you can click on the Hot 2000 exporting button. And what it will do is that it is going to download this design as a Hot 2000 file. And you can easily just go, it's already downloaded for me here, so I can just go and click on it and open it up. So it opens up and all of the information that I put in is inside this Hot 2000 file, including my window sizes, the kind of the details of that, and basically all of that. Now, one thing I want to highlight is that, of course, this Hot 2000 file is not complete. This is simply an StepWin export, as we just said. This has no function without a professional to come and maybe complete it. More importantly, keep in mind that your energy advisor may not even use this Hot 2000 file. It is just have been created to speed up the process and also show the design in a format that's familiar with everybody else. So the last point is that please we have fairly short terms and conditions and disclaimers about StepWin. Please please take a minute to go over them. StepWin is not a replacement for energy efficiency or any sort of professional service. It's a service to help you come up with better designs and hopefully speed up the construction process as an additional tool, but you have to consult with the professionals for any decision making that you are planning to have. Now, it's 2:55. I have a few minutes for any questions that you may have. And we are looking forward to seeing how you will use this software and use StepWin to create new accounts. Any questions, please feel free to either unmute yourself and start asking, or just use the chat function on the live stream or inside. Okay, is it ventilated to actually standard 140? The short answer of that is no. We have a particular a ventilation assumption based on kind of the archetypes that was also used in the step code studies. But we are also thinking, working on making that more flexible. So if you want to use your own numbers or you want to use one of the standards, you can do that, but not at this time. Another question, I did not see a cost for this service anywhere. Oh, can you speak to that? Oh, for sure. If you are a builder who wants to build in the city of Kelowna, in the city of Port Moody, city of New Westminster, or city of Penticton, this is available for you free of charge. If you put in another region, we will have a pop-up that will tell you that, please contact us. We are working really hard to expand it to new regions as fast as we can, but this is where it's available right now. Any other questions? Yes. Will it do HVAC calculations to F28012? Again, our calculations are based on a particular assumption that was also in the BC Step Code Metrics study. One thing for you to think about is that there are a lot of different opinions about what is the right rate of ventilations, at least from the people that the mechanical engineers I've seen. We are trying to create some sort of a balance or some functionality that is not too complicated for people at the very earliest stage of the design, but also is providing kind of everyone's is having everyone's intent in mind. So not at this time, but it's just basically the assumption based on that study. Does this apply to renovations as well? We are working really hard on making a step code expand to multi-units. This is only single families right now, and also hopefully very soon renovations. It should be coming in around the time that we have also some sort of a framework by someone in the province, because we are also not sure how it's that going to look like when it comes to renovations. And if you subscribe to our updates, we will make sure to give you news as we receive it. Is it free for builders in 4 jurisdictions mentions? How is the software funded? Very good question. Partially, we are funding this service for those 4 jurisdictions for 1 year, thanks to a Clean BC Building Innovation Grant. We didn't really feature them because they asked us to kind of wait for their marketing materials to come in. Beyond that, out of these 4 regions, we are also looking at how we can work with other players in the industry to deliver this software maybe faster or in other ways with the builders. We are kind of finding that method that's giving us the fastest growth inside the province. So the software is right now at some degree self-funded by us, to some degree self-funded by grants, and that's essentially how we are kind of providing you all of these services. Is the window and door U, solar rating coefficient, ER, etc. generic or a specified manufacturers? They are generic, but also keep in mind that these are coming from some sort of an averaging of all of the manufacturers that we have been in contact with. I have and my colleagues, we have called, I think, like once every manufacturer that we could get our their contact information on, and ask for some preliminary stuff. Also, Hot 2000 has its own standard numbers, but it's important for us to make sure that we are relevant to the job site. So if you know a window and door manufacturer who can give us more ideas about their costing and sort of stuff that they're providing, and they feel like this is not quite tuned to what they can provide, please let us know. We are very quick in adjusting our numbers and making changes. Is performing for mechanical system, thermal efficiency, COP, etc., and input. Not right now. We have generic assumptions for a heat pump, high efficiency boiler, and also the furnace. The reason we do that is that there is a kind of we didn't find quite a broad band with what is the minimum building code is providing, and also the premium stuff that are out there. So it's somewhat of an average between the somewhat premium system and somewhat basic systems. I know that many people would prefer to, even if you are a mechanical system designer, prefer to put in your own numbers, especially if you have a very unique system. And we also think about how we can put that functionality in there. But at this time, it's based on those generic numbers that we have. We felt that it's going to be kind of the middle ground of everyone. Could you please share your contact information? Absolutely. So if you are in the StepWin, this chat function is probably the easiest way you can contact with us. Also, we are available via info@stepwin.ca. Also, if you want my personal email, it's arman@lambda.science. And our website is lambda.science. So I'm putting this also in the chat function as well. After the webinar, we will also send you a care package if that helps. Just a quick information about the phone numbers and all of that as well. No problem. Any other questions? Okay, that was some really good questions. Okay, nothing else. Just going to wait for the live stream folks to see what we are doing there as well. Okay, got a like, that's not bad. Yes, thanks, Clark. Thank you everyone for joining. I will be monitoring this chat. Okay, yeah. It looks like a useful program for builders. Thank you so much. Thank you. Will any future versions, will you be able to import geometry from a file? Wow, that's a question that we get a lot. And thank you for asking that. We are kind of thinking about what would be the unifying format that everybody is going to use, but we are hoping that you are starting to use StepWin before actually having a sort of AutoCAD or Revit file. We are hoping that you kind of close your eyes and think about what sort of building mass is going to look like, and then put it in the StepWin and base your design out of that. I understand that if you work it the other way, it might seem a little bit cumbersome to put in all of the numbers in, but hopefully that's gonna also, as we move forward, if we see this request coming pretty frequently, and if there is a one extension that people on one software, we will be sure to provide it. How did you make your results show? I ran the program but can't view the results. Regan, let's. I think we have to see this probably for your particular case. either like give it a few seconds, it might show up, or there is something that I need to look into, but depends on what you're doing. But yeah, I'll be happy to take this offline and talk with you about it. But yeah, if you have gone to the run page and click on refresh, it should either give you, like, maybe you don't have enough roof for the walls or something like that, or it will just run it. Will this presentation be available later? We will send you a link to the recording. Yes. Thank you so much, Adam. Thank you, Haley. Okay, thank you, everyone. Have a great day. I hope you are keeping safe. Yeah, and we will be finishing this webinar in just a moment.